Hello students, this is Mr. Sims, and I have a new and improved video for identifying proportional and non-proportional relationships in graphs starting on page 42. So our opening exercise, Isaiah sold candy bars to help raise money for his scouting troop. The table shows the amount of candy he sold compared to the money he received. So X is our candy bars sold, Y is our money received. Is the amount of candy bars sold proportional to the money Isaiah received? Okay. So going back to something we did at the very beginning, do they have the same unit rate? This is the first recording that I've done of the new school year, so bear with me if I make mistakes along the way. So what I've done is I'm going to check to see if it's proportional by following. So I've got my first y over x is my 3 over 2, which is 1.5. And then I've got 5 over 4, which equals 1.25. So we'd say that this is not a proportional relationship. And how do we know? No, it does not have the same unit rate, because that's been the thing that we've really focused on. Right? So in this video, I'm going to go through example number 1, and I'm going to go through example number 2. Two examples to kind of determine one of them will be proportional in a graph, the other one will not be proportional. So let's start with example number 1. From a table to a graph. So that's the first thing we'll practice, is how do we take information that's in an XY table and put it on a graph. This should be review. Right? Using the ratio provided, create a table that shows the money received is proportional to the number of candy bars sold. So up here, it wasn't proportional, but we're going to make one down here that is proportional. It does have that same unit rate. Right? So 2 candy bars sold for $3. So what if I sell 4 candy bars? What if I sell 6 candy bars? What if I sell 7 candy bars? Actually, not 7. Let's make that 8 so these numbers come out nicely. So now I've asked you to go ahead and fill in this information. So 4 was 6, 6 was 9, and 8 was 12. So now what we're going to do is we're going to plot these coordinates, which would be 2, 3, 4, 6, 6, 9, and 8, 12. Right? And like so. And so 2, 3, hopefully it's a review. X coordinate, Y coordinate. So this is the x-axis, this is the y-axis. So this should be a little bit of review. 2, then 3 would be to the right 2, up 3. Plot it. Okay. 4, then 6 would be to the right 4, up 6. Don't forget that you can pause these videos at any time if you are having trouble keeping up. 6 becomes 9. 8 becomes 12. Then we take a ruler. Okay, and you'll be using rulers. Make sure you grab one. If you don't have one, pause this video and go get one now. And we draw a line through. And this is a proportional relationship because 3 divided by 2 equals 1.5. 6 divided by 4 is 1.5. 9 divided by 6, 12 divided by 8. So we know that they have the same unit rate. And let's look at the graph. Right? So that brings us to the next page. Characteristics of graphs of proportional relationships. There are really 2 things you're looking for. First thing, is it a straight line? The line has to be straight. Right? It may look like it's straight, but it's got to be completely straight, perfectly straight. And then the second thing, it must pass through 0, 0, or the origin. The origin of the graph is 0, 0. But we've talked about that before, about if, for example, going back to this previous problem, back here, flipping through here, back here. If you don't sell candy bars, how much money should you receive? It should be 0, 0. Okay, so those are the 2 characteristics that we're looking for, and this is part of the objective. You'll be able, some of you are going to get this very quickly, and this might be one of the easiest things we do all year. All right, example number 2. In example number 2, we're going to graph the points provided in the table below and describe the similarities and differences regarding the graph to example number 1, which you may have to reference in order to do this. Okay, so I'm plotting the points now. You should already have these plotted. 9, 15. I'm also still working out the kinks on. I'm also still working out the kinks on Edpuzzle as well. So there's the line through. All right, hopefully that's what you've got. All right, so another question is, does this table show a proportional relationship? Do they have the same unit rate? Well, if I start here in 6 divided by 0. You can't divide a number by 0. Right? But even if you went to the next one and you did 9 divided by 3, 9 divided by 3 is equal to 3. But then when you do 12 divided by 6, it's equal to 2. It's not proportional because they don't have the same unit rate. Right? Now, looking at the graph, there are some similarities with the first example, and there's a major difference from the first example. So the similarity with the first example, flipping back quickly, is that they both seem to be a straight line. So both lines are straight. The major difference from example number 1, and let me go back to it one more time just so you can see it. Here's example 1. This one starts at 0. This one does not. It starts at 6. Does not pass. And actually, we should say the word pass through because that's really the term we're looking through. 0, 0. So in closing, graphs that are proportional will start at the origin or pass through the origin and be a straight line. Graphs that are not proportional will not start at 0. And also, consider graphs that aren't straight as well. All right, so that is the end of this lesson video. So moving on, just follow along with your checklist. You have exercises on page 40. So this is Mr. Sims signing off.